Hello everyone, and welcome to this webinar about SNAP-A-Map and how it can be used to create maps to SNOMED CT-AU. This webinar assumes some basic knowledge of SNOMED CT-AU and the AMT, such as what are concepts, descriptions, subsets, scope and content coverage, and hierarchies, which I won't go into any detail. You can check out the document library on the National Clinical Terminology Service website for introductory webinars about these topics. Now, this webinar describes the features of a mapping tool. When it comes to mapping, you can develop your own tool or choose not to go with one. This webinar will go through a tool that is available when you wish to map to SNOMED CT-AU. Hopefully what you will get out of this session today is an understanding of how to access SNAP-A-Map, learn about the features of the tool and how to work with it efficiently, and finally an understanding of how it supports not only the initial mapping process, but ongoing maintenance of the map. So Snapper is a tool that supports the creation and maintenance of terminology maps. It is optimized to map to SNOMED CT, and specifically it works with FHIR technology. Now FHIR stands for Fast Healthcare Interoperability Resources, and it's a next generation standard for the way healthcare information is transferred between systems, but is also a specification of how terminology can be managed. In a later slide, I will talk a little bit more about FHIR resources, but just know that the tool tries to hide as much of FHIR as possible to a mapper. In this webinar, I will describe a workflow for mapping a simple local code set to the Australian Medicines Terminology, AMT, which is part of SNOMED CT-AU that is hosted on the National Terminology Server. Snapper was developed by the Australian eHealth Research Centre of the CSIRO, like the Stream Terminology browser if you're familiar with that. And the Australian Digital Health Agency has a licensing agreement to make Snapper freely available for use in Australia. The features of Snapper is that it uses a web-based browser such as Chrome or Firefox. It has an Automap function that matches descriptions in your local dataset to descriptions in SNOMED CT. It supports maintenance by finding maps to inactive concepts and suggesting replacements for you. And it can also store maps in a local Onto server instance, which can then be used for translation operations. I won't go through the last point today, so please contact us if you're interested in how this works. To be able to use Snap-A-Map, you must be a registered user of the National Clinical Terminology Service, or NCTS, because you are accessing SNOMED data. There is a link here to register as an individual or organization, but just as a note, if you are part of an organization that is already registered with us, you will need to track down what we call the responsible user within your organization to provide you with access to the NCTS website. If you have any issues with this, please contact our help center. Once you have credentials for the NCTS website, which is a healthterminologies.gov.au username, you can then access Snap-A-Map using the link here that you can also bookmark, which will prompt you to log in with those credentials when you're within the tool, or you can log into the NCTS website first, then go to the Tools section, select Snapper, and then click on the Access Snap-A-Map link. So here is the landing page if you have logged into the NCTS website first. If you didn't, there will be a pop-up that asks you to confirm FHIR server authentication, which just means log in using your NCTS credentials. In the middle are some tours you can take that step you through the user interface and workflow, and I encourage you to try those when you've accessed Snapper for the first time. And there's also a link to documentation. On the left-hand side is where your maps will be, and at the bottom is a status bar which tells you when things are happening, like Automap, or if there's an error. Now the tool by default is connected to the National Terminology Server, and the address is shown on the top left-hand corner, but there is an option to change that to your own local terminology server like Onto server if you have one. It's through the settings button on the top right-hand side, but I won't show you that today. Just a bit of context about the example mapping I will go through today. I have a local list of medicines and I want to map that to the AMT, specifically the Container Trade Product Pack Concepts, or CTPPs. I will also access the National Terminology Server as I don't have my own FHIR terminology server. Let's create a new map. The first thing to do is click on the green plus icon on the left here next to Classic Maps. This will prompt you to fill in some metadata or information about the map. You will need a little bit of knowledge about FHIR at this stage, so we'll take a little detour here. As I mentioned before, FHIR is a way that terminology can be represented, and there are 3 FHIR resources that you need to be familiar with. These are called Code System, Value Set, and Concept Map. Code System defines the total set of codes for a particular domain, which for example could be SNOMED CT for clinical terminology, LOINC for laboratory procedures and observations, Meteor, which describes healthcare metadata, or it could be locally defined. So here on the right, I have my own local code set for Australian states and territories. Now a value set specifies a list of codes taken from one or more FHIR code systems for use in a particular context. It provides value to the user because it contains a practical list of codes for a particular use. So here I have a local value set representing mainland jurisdictions only, that is excluding Tasmania. However, a value set can represent an entire code system because sometimes it is useful. So here on the left, I have a value set representing all of SNOMED CT codes. Finally, a concept map represents the relationship or mapping between codes into different value sets. Here I have a concept map for my local value set of mainland jurisdictions, which we will call the source, to SNOMED CT, which we will call the target. The mapping is in one direction, usually from source to target, and the map also contains information about how equivalent or not those concepts are. So back to the tool, which creates FHIR concept maps. When you fill in the metadata, there is a bare minimum you need. Give your map a name, and it is also useful to have a short description about what the map is and its purpose. Now SnapperMap is optimized for SNOMED CT, so the default target value set is all of SNOMED CT, but generally you don't want Automap to be searching through all of SNOMED, rather a relevant subset. The easiest way to do this is to click on the magnifying glass to select a predefined SNOMED CT-AU value set, which will bring up a drop-down listing of our reference sets, for example the adverse reaction agent reference set and so on. In this example, I will select the Container Trade Product Pack reference set. I'll go through some of the other fields here that are only relevant if you're working with your own FHIR terminology server. The URI, or Unique Resource Identifier, is automatically populated, but you can specify it if desired. If your local code set is already represented as a FHIR resource, you can define them here in the source. However, most of you will be importing codes from a file, which is why you can leave this source section unchanged. Finally, at the bottom is a list of mapping relationships, which if you recall indicates the type of relationship between the source and target. The default relationships are equivalent, unmatched, wider and narrower, and the types ticked here will be options available to a mapper. So once I fill in the metadata, a blank new map is created. I've given it a name of my example map. The mapping editor button is here, and it is important as you will access all functions from this menu, and I'll touch on almost all of these on the webinar. The fourth option down is metadata, which will bring you back to that window you filled in before and allow you to adjust the target value set and mapping relationships as needed. Now the next thing you will want to do is add source data to your map. Most of you will be importing codes from a file saved on your computer, and I will go through the import wizard with you. But just know that you can manually add any number of rows by clicking on Add Row. Now there are a few things you need to do before you import your codes. Firstly, the file must be in CSV or TSV format, which is easy to generate from Excel if you need to. And next you need to ensure that you have less than 20,000 source terms because the tool cannot physically hold that much data. If you have more than that, you will need to split the file into smaller chunks, and in reality, this might make the mapping exercise more focused and easier to do. The other thing you need to prepare is that all your source terms are in one column. What that means is taking medicines, for example, if my source data had brand name, form, strength, pack size, and container type in each individual column, I would need to concatenate that into one cell so that the tool doesn't need to take several columns into account. So from the Mapping Editor menu, I selected Import Codes, and obviously the first step would be to browse for the file saved on your computer, and then select the file type. A preview of your source data will be shown here, and the total number of items, which reflects how many rows you'll be mapping. If your file had column headings, you can select the number of rows to exclude these from the map itself. Now the next part is to assign which column in your source data should be loaded into which column in SNAP-Map. The minimum you need to import are your source codes and source terms. So the first thing to do is to click on the source code button, and you can see the button looks depressed. And then you click anywhere in the body of your code or ID column. The source code button will turn green when data has been assigned to it. Then you repeat for the descriptions, that is, you click on the source label button and then the body of the column that contains your descriptions, and the source label button should also turn green. Now if your local dataset doesn't have codes, only descriptions, you can still import your data. You would assign your descriptions column twice, first as a source code and then the source label. You are also able to import a map, so you can assign target code, target label, target relationship if you want, and also any comments if your file includes notes. Finally, click on Import. Here is my imported data where descriptions are shown in the source column. Underneath the table there, you have some stats in terms of how many rows there are, how many of those are unmapped, and how many are selected. The next step is to find targets, either through Automap or manually. So let's talk about the Automap feature. It works by comparing the descriptions in the source, your local data, to the descriptions in SNOMED CT. It saves you a bit of time instead of searching through the terminology yourself. First, you need to select the rows you want to map. You can find a shortcut to select all rows from the Mapping Editor menu, or you can highlight individual rows or groups of rows. Any selected rows are highlighted in a pale blue color. Once you have your rows selected, go to the Mapping Editor menu and select Automap, which will bring up the Automap options. Now, the strategy determines the rules that Automap will follow. Strict matches most words applied, default will match a few words, and experimental is a looser algorithm that allows partial word matches. We do recommend running Automap twice when mapping source data for the first time. First choose strict to find precise matches, and then find any unmapped rows and run experimental. This reduces some effort when validating Automap. Next, select the direction, which is almost always from source to target. And finally, you have the option to overwrite existing target codes, but I would leave this unticked unless I deliberately wanted to change any mapped rows. Once these options are set, click Go and there will be a progress bar at the bottom of the screen. Now the time it takes depends on your connection to the server and the number of rows to be mapped. Generally, it should only take a few minutes. You can interrupt Automap if you need to, or better yet, run Automap in smaller, more manageable batches. So here I have my local data mapped to SNOMED CT, and you can see all these other columns are now filled in. The top match is shown in the target column, but there may be others that you can see from a drop-down when you double-click on the cell. And indeed, you can choose one of them if they are a better match. The next column is category, which relates to the SNOMED CT hierarchy that the target concept comes from. In this case, if you remember, I constrained the target value set to the Container Trade Product Pack reference set, so all the targets will be CTPP concepts. The map type or relationship is always inexact when Automap has been run on a row and needs to be adjusted when validating. And finally, the status allows you to track the workflow. In this case, it is telling me Automap decided the target. So the next part is to review the mapped rows. But first I will zoom out to show you the other parts of the screen that helps you evaluate the target. When you click on a row as highlighted in blue, the Hierarchy Panel and Properties box gives you more information about the target concept, and you will be familiar with these if you have previously used the Shrimp Terminology browser. Just briefly, the Hierarchy Panel shows you the concepts associated with a target concept via an ISA relationship, and the Properties show you the descriptions associated with the target concept. On the top right, I can search for terms within the target value set, which is what I will go through next. I can see in the second row, highlighted, that a Zygen product is mapped to a 3TC product, which is not correct. So I type in 3T240 and possible matches are displayed underneath. I click on the top result, which is a 3TC product, and the hierarchy view and properties of this concept are now displayed. I look at these and decide, yes, this is the correct concept. So now I can either drag and drop the search result into the target column, or drag and drop the code from the properties box into the target column. Either of these methods are fine. When I change what was in the target column, the status automatically changed from Automap to draft, which indicates the human has made changes to the row. It will also change when you are happy with the target, but update the map type by double-clicking on the cell and choosing from the drop-down. Now, if you remember, we had some mapping relationships ticked in the metadata window. So the ones that were ticked there are the ones that will be available in these drop-downs. In this case, I would choose equivalent. Finally, you may want to add some free text notes in the last column. Say you want to include the reason for mapping or potentially flag something about that map for the reviewer. So I'd go through each of the rows one by one, checking if the target is okay and assigning a map type, or if it isn't okay, then searching for a better match and then also assigning a map type, until all rows have a status of draft. The next step is to hand it to a reviewer who follows the same process to validate each target is appropriate, and if they're happy, then they can change the status to final. If not, they can change the target and the original mapper can review that. Note that if both can't agree, there needs to be a conflict resolution process in place, for example, another reviewer brought in. Now let's go through some tips for working with SnapMap to make the process a bit more efficient. You can find drop-downs on each of the column headers for ways to work with the maps. All columns can be sorted in alphabetical or reverse alphabetical order, and can be handy, for example, if you choose sort descending on the target column. This way you can group blank or unmapped rows at the top. Some columns allow you to clear either from selected rows or all rows, but do be careful that clear all will clear all values in the column, whether the row is selected or not. Also, some columns allow you to assign a particular value to several rows at once. So here in the map type column, I can set a whole bunch of rows to equivalent, or whatever is appropriate. And remember, these were the same map types chosen in the metadata window. I cannot stress enough how it makes mapping so much easier when you focus on a small set or a particular group, because it's easier to remain consistent when applying rules during the mapping process. For example, I might want to work only with amoxicillin products, or procedures that are a type of oscopy, or clinical findings of rash. So I go into the Mapping Editor menu and click on Toggle Filters down the bottom. And what will happen is these filter boxes will appear in each column header. Type in the term you want, and when you're done, click on the X to the right of the box to remove it. Of course, you can filter on more than one column at once. If you want to hide the filter boxes again, just go back to the Mapping Editor menu and select Toggle Filters again. You would have also noticed that the default view of the map is only the descriptions, without the codes. This is because the codes are not as important in the mapping exercise, although are a key part of the map. But if you do want to see them, go to the Mapping Editor menu and you can show source codes and show target codes. And now they will appear. If you want to hide them again, go back to the Mapping Editor menu and you will see the option to hide source codes and hide target codes. Finally, you will probably want to download your map. Now the maps you are working on are saved in your local web browser in the current state, so there's no versioning available. It is good practice to download your mapping work often so you can do some sort of version control, and to protect against, for example, clearing the browser folder, or when there's an update to your browser, you might lose that map. Also, if you use the same browser on a different computer, you won't see your map. And likewise, if you open Snapper from a different browser on the same computer, you won't see those maps. So you need to download to transfer the maps. From the Mapping Editor menu, you can download as a tab-separated file, which you can work with separately in Excel if necessary. Or, since it is a concept map, you can save it in a FHIR JSON format. Now, since Snapper is designed to work with a terminology server, there is an option to upload it to a local server, which I won't go through today, but note that if you are working with a national terminology server, you can't upload to that as you only have read-only access.
Here I will quickly demonstrate the Snapper mapping tool. I have a bookmark on my browser, so I'm going to access it through that. And because I haven't logged into the NCTS website already, it's asking me to do so. So I'm going to click on Login. I'll choose my healthterminologies.gov.au account and type in my password. So here I am, and I want to create a new map. So I click on that, and basically my list of terms are pathology tests, specifically panel test names. So I'm going to call this lab tests, and I will give it a description of map of panel test names to SNOMED CT-AU. Now my target value set will be the procedure foundation reference set. So I'm going to click on the magnifying glass down here, and then in my predefined drop down, I'll scroll down and get to the procedure foundation reference set. So I'll click OK and I'll click on done, and there is my map. So now I'm going to import my codes. So I go to the mapping editor menu and click on import codes. So I'll browse for my data, which is in this text file, and then I'll choose TSV. But basically, I know that my list is a flat list of descriptions, so there is only one column available. I can also see the header name that I've got in my data, so I'm just going to go back up here and select one for the number of rows for the header. Now I need to assign source code and source label, and because I only have one column, I'll assign it to both. So source code, click on the body, source label, click on the body. They've both turned green, and now I'm going to import. And here is my data that's in the source column, and I have 92 items that I want to map. So I'll go back to my mapping editor menu, select all rows, go back to the mapping editor menu, and then select Automap. Now, normally I would run it twice. I would run strict first and then validate those rows, and then on anything unmapped, I would run experimental. But in order to show you as much of the tool as possible right now, I'm going to select experimental for everything. The direction is from source to target, and I'll click on Go. And down here in the status, you can see it is auto mapping, and it's also giving me its progress. So just let that run. It'll probably take about a minute. Okay, so here we are. And Automap has matched 91 of 92 items. And also up here, you can see that there is one unmapped item. Now, I should say with my source data, I didn't pre-process it. And you can see with the first one how I've got sample cortisol, which doesn't accurately represent a test name. It is more the sample that is associated or used for a test. So you can see the benefit of pre-processing the data before attempting the mapping process. Now I'm just going to widen my source and target columns so I can read the descriptions a bit better. So with the first one, Automap has chosen sample analysis, which isn't quite right. So I'm going to go over and search for cortisol. And you can see there is a top result of cortisol measurement. I'll click on that. And then when I look at its concepts around it and also the descriptions, I think, yes, this is an appropriate map to make. So I will click on cortisol measurement, drag it across and drop it into the appropriate target cell. Now the status has automatically changed to draft, and what I need to do now is select the map type of equivalent, because that's what it is, and that row is done. So the next row, it looks fine to me, so I'm going to select that as equivalent. Now the third and the fourth rows are also incorrect. And let's say I've gone through the process of manually searching for a better target, but I didn't find one. So I actually need to clear these targets. So I will select on those two rows, go to my target dropdown and choose clear selected. The map type will be unmatched and the status is draft. So one thing I wanted to show you as well, just quickly, is to be able to filter the terms. So I'm going to my mapping editor menu and select toggle filter. And then here I'm going to type in cortisol. So now any of my source terms that have cortisol in them are together, and that allows me to handle these terms in the same way. And so that was a very quick overview on the Snapper mapping tool.
So let's talk in general about some things you need to consider when mapping. Obviously, make sure you are following good mapping principles, which is around defining the use case, scope, purpose of the map, pre-processing the source data, and documenting decisions, rules, and processes. We have published a set of mapping guidelines to SNOMED CT-AU and the AMT, which is available on our NCTS document library. With regards to where you want to direct your effort, I just want to call out there are a few options around the workflow. For example, single map, single review, which is probably the minimum, single map, dual review, and finally, probably the most optimal is dual map, single review. But it depends on the content being mapped, clinical risk, team experience, and resourcing available to you. Ideally, you want to have equivalent maps as much as possible for ease of interpretation and reproducibility, but it is possible to have, for example, a SNOMED CT target that is broader in meaning than your local code, for example, mapping neomycin sulfate to neomycin. Now, not all of your local concepts may be found in the terminology. If it isn't in scope, then no map will be expected, but you will have to be aware that these exist in your data and what the implication is. But if it is in scope, you can submit it to us via the request submission page on the NCTS website or contact our help center. With Snapper itself, just be aware that it is optimized to handle simple maps where the mapping does not require additional business rules. So for example, if your local code of A plus B together maps to SNOMED code X, well, Automap won't be able to cope with that. However, it does handle it if A and B separately map to X. Also, remember that 20,000 rows is the limit, and large maps can be slow to work with. Maintenance. Now, maintenance is very important when you undertake mapping because maps don't age well at all. You need to review maps every time either the source changes or the target SNOMED CT-AU changes. Just be aware that SNOMED CT-AU and the AMT is currently updated monthly, so you need processes in place to at least handle that frequency. When you review a map, you need to follow the same business rules and mapping process as when you did the initial mapping to ensure consistency. Snapper Map can check if SNOMED CT-AU targets have become inactive and suggest active replacements for you, and I'll quickly show you that now. From the Mapping Editor menu, choose Select All Rows and then Select Inactive Targets. The tool will highlight rows with inactive concepts, and the status bar at the bottom of the screen will also show you how many inactives there are. Keep those rows highlighted, go back to the Mapping Editor menu and select Migrate Selected Rows. Basically, there is a workflow that will take you through the historical association maps, which is data already contained within SNOMED CT that says, for a given inactive component, what is the alternative current active component? There are 4 maps the tool will take you through, and it will show you what you've mapped and the suggested replacements. And when you click Apply, a summary will tell you how many changes were made. In your mapping, the target will be updated. Here the container type changed from blister pack to a dry powder inhaler, and the status will change to draft, and it is ready for someone to review.
Here I will quickly demonstrate how to maintain a map using the Snapper mapping tool. This is the map I have, which are terms related to clinical findings and disorders that are associated with skin structures or wounds that would be reported in an emergency department. In this fictitious example, the data was last reviewed in January 2017. So first I will expand my source and target columns. Now I have some unmapped items and I want to work on them first. So I will go to the map column and sort descending to get the unmatched items up the top. I will select the first 4 rows, go to my mapping editor menu and select Automap. I'll just keep it as default, go from source to target and click on Go. And Automap has done a fairly good job in finding appropriate matches, except for the second one. And I'll quickly search for zombie. And no, there's nothing in the Australian Emergency Department reference set relating to zombies. So I will keep that unmatched. So I'll clear selected, make it unmatched, and make it draft. So to complete this workflow, I'll just select the other three rows, make them equivalent, and also make them draft. Okay, so the next thing to do is to find any inactive targets. So I'll go to my mapping editor menu and select all rows, and then select inactive targets. And I'll let that run. And what's happened now is that there are 14 rows that are selected. And if I go down to the status bar as well, it tells me that there are 14 rows with inactive target codes. And I'll scroll through them as well so you can see they're throughout the map. Now the first one, pseudo knuckle pad, is showing here in the hierarchy view and it's yellow, and the inactive property is true. So that confirms that it's an inactive concept. So with those rows still highlighted, I'll go to the mapping editor menu and migrate selected rows. Now there are 4 maps that I could go through, and I need to go through all of them to find any replacements. So the first one is replace by. I'll just click next, but there are no migrations found there. So I'll click on back, click on the second one, same as, then click on next. And here it's found 8. So on the left, it's showing me the inactive targets, and on the right are the replacements as suggested by the data. Some of them have different preferred terms, but basically you would go through the list and analyze whether it's appropriate to apply or not. They are ticked by default, and yes, I will accept them as suitable replacements. So now I click on apply, and it's telling me that there were 8 changes made to the targets, resulting in no additional map entries. So I'll click on done there, and you can see that the new target is now available in that cell. I will click on that, and indeed you can see the hierarchy view as well as the there is no inactive data property. So this is the current active target, and the status has automatically changed to draft as well to indicate there was a change made. Now, if you remember, there were other inactive targets that were found. So I'll have to go back and repeat that workflow, select all rows, select inactive targets, and now there are 6 that are still remaining, and I would go through migrate selected rows and find the appropriate matches for them too. And that's a very quick overview of how Snapper helps you to keep maps up to date.
Thank you for watching this video. If you have any questions, you can contact us via the Help Centre. Details are on the slide here.